All right, so today we're going to finish up our discussion of the hydrogen atom. We started on Monday talking about radial probability distributions for the s orbitals. We'll finish that up, and then we're going to move on to talking about the p orbitals. We'll start with talking about the shape, just like we did with the s orbitals, and then move on to those radial probability distributions and compare the radial probability at different radius for a p orbital versus an s orbital. And once we do that, we're actually going to move on to multi-electron atoms. So you might have noticed that we will have spent about 6.5 lectures just getting to the point where we have only one electron, so we're only up to hydrogen so far. And you might have kind of been projecting ahead and thinking if we keep up at this pace, pretty much we would only get to carbon by the end of the semester. So I will assure you that we will not be spending 6 lectures per atom as we move forward. And in fact, what we're going to find is that by taking all the principles we've learned about the hydrogen atom and applying that to multi-electron atoms, but making a few changes and making a few modifications to take into the fact that we're going to have electron-electron repulsions going on, we'll be able to think about any multi-electron atom using these same general ideas and the Schrodinger equation ideas that we came up with and have looked at for the hydrogen atom. And this is really good news because it's good to get past carbon. I'm an organic chemist, so I love carbon. It's one of my favorite atoms to talk about, but it would be nice to get to the point of bonding and even reactions to talk about all the exciting things we can think about once we're at that point. So once we finish our discussion of how we think about multi-electron atoms, we can go right on and start talking about these other things.